Hello, hello. So today we're going to read the pytorch documentation for fun. So my plan, obviously you won't be able to read the whole thing, but we don't want to read the whole thing. We want to read the basic things and move on, right? Also, I would like to read some specific things. Like I want to know what something called ainsum, uh, like ainsum or something. It's some kind of way to do matrix multiplication. So I want to know what exactly that is. And similarly, we'll note down fun things here. So that's the plan. Yeah. So before we start, just ensuring the stream is live. Um, I cannot hear anything. I know. Am I not connected? Yeah, I was not. I am not sure if I'm live. Okay, I'm live. All fun. Wait. So, right. So this is reading by Tars Sucks. So guess we're going to read it, huh? Right, PyTorch is an optimized and set library for learning for deep learning using GPUs and CPUs. Okay. The feature will be maintained long term and there should be generally no major performance limitation or gaps in the documentation. Really. You also expect to maintain backward compatibility. All the breaking changes can happen. A notice will be given one release ahead of the time. Beta. This feature tagged as beta because the API may be changed or the user feedback based on user feedback because the performance need to improve or because coverage across the operators is not yet complete. For beta features, we are committing to seeing the features through the stable classification. We are not, however, committing to backward compatibility. These features are typically not available as a part of binary distributions like Piper or Conda, except sometimes behind runtime flags and are on early stage. Okay, probably these are like these will be available only if we source it via GitHub. Community developer nodes language API. Okay. I think I want to start somewhere here. Let's just read through. Not well, but just read through. GP accelerator Python tensor. Contributing dot markdown. Unit testing. Hmm. Honestly, I kind of want to start contributing to GitHub. Like PyTorch more. Getting started. Proposing new feature. New feature ideas are best discussed on specific issue. Please include as much information as you can. Any accompanying data and your proposal is the way PyTorch team and community frequently review new issues and comment where they think they can help. If you are confident in the solution, go ahead and implement it. A great deals of tutorials on PyTorch all come from community itself, and we welcome additional documentation contributions. To learn more about how to contribute to a new tutorial, you can improving documentation tutorials, participating in online discussions, promoting PyTorch. Triaging issues. If you feel that the issue could benefit from a particular tag or level of complexity, comment on the issue and share your opinion. If you feel an issue isn't categorized properly, comment and let the team know. Common mistakes to avoid. Did you attest? Is a PR too long? Comments for several things. Please include extra comments and documentation. License is a hack. Do, do you want to touch a very core component? Particular touch core component receive extra scrutiny, obviously. Want to add a new feature. Did you code touch code unrelated to the PR? Did you touch code unrelated to the PR? Uh, Okay. Philosophy. The document is designed to help contributors and module maintainers understand the high level principle that has developed over time in PyTorch. They are meant to be hard and fast rules, but serve as a guide to help trade off different concerns and resolve disagreement that may come up while developing PyTorch. Principle 1, usability or performance. This principle may be surprising. As when hacker news pass, PyTorch is amazing. Although I'm confused, how can an framework not be observed as speed or performance? Hacker news discussion on PyTorch. Article was a good read. Although I'm confused, how can an ML framework be not obsessed with speed or performance? And the secondary focus is not to look like clones in the performance department. We try to take one decision that trade off performance usability and vice versa. But okay, sure. So they are not obsessed with speed or performance. PyTorch's primary goal is usability. Secondary goal is to have reasonable performance. That's fine. That's cool. We believe that the ability to maintain our flexibility to support researchers who are building on top of our abstractions remain critical. We can see what the future of what workloads will be, but we know we want to we want them to be built fast and PyTorch, and that requires flexibility. Mm. The performance may not be worth user friction. That's fun. Either because the performance benefit is not compelling enough or only applies to a relatively narrow subset of problems. Relatively narrow set of subproblems. Even if the performance benefit is compelling, the restrictions can fragment the ecosystem into different set of limitations that can quickly become incomprehensible to the users. You want to be able to seamlessly move the PyTorch code to different hardware and software platforms, to incorporate with different library and framework, and to experience the full richness of PyTorch user experience. Simple or easy. We borrow from Zen of Python. Explicit is better than implicit. Simple is better than complex. The principle in Python that encourages clear, straightforward code. Some classic arguments in favor of this. Linear model results into very different performance characteristics to uniformly. The details will leak. A caveat here is that this does not mean the higher level LCAP are not valuable. Certainly, there is a value in, for example, the higher levels in the stack is supported. Python first with best of Python first with best in class language interoperability. Fun fact: I've never used SciPy in my life. I think I should like read documentation of SciPy once. Uh, okay. Developer notes. Automatic mixed precision examples. I don't know what that is, but we'll see. So I think let's make a simple model in PyTorch. So we can like, I almost forgot again, but we'll try. So we'll go like, before all of that, is the Vim debiting somewhere? No, right? Oh, that actually is. Let's go. Oh, that's so cool. But how will I? Oh, is there some way to move to the next? What do you call it? Yeah, the only way to move to the next cell is by array, which is not optimal to say the least. So let's start with first we have to make data set. So x equal to, okay, sure. Let's do x dot shape and y dot shape. Let's also come here. Let's replace it by y and run new. Okay. So how can I make a model? No, I want to make a node, right? So class neural net, and I think uh, okay. Honestly, yeah, but before that, I want to do import torch dot nn as nn. Yeah, I'll do as nn. Yeah, I'll do this too. Well, okay. What the hell is that? Okay, bro, I don't get. This is imports, bro. What do you mean? Okay, how can I remove this? Generated code may be a subject to license. What is it called? Column. But now, even go away. That's sad. Okay, we have this. Now we have to define forward pass. No, wait, that is during the training. Or, yeah, I should, I think. Define forward of x. Return x. Uh, yeah, that's right. Oh, my bad. I forgot you. Okay, now we have to construct a neural network. So the neural network will be yeah, I don't want user, and this is so much worse than Copilot 3, and it will be like, let's say 10 comma me 10 comma 10. You'll be uh let's say 5 comma 5, and you can also be 5. You can also be 5. You can be self dot fc3 of the whole thing. Now we can start the training loop. The model equal to neural network. Now what can we do? What should we do? So we want the loss function optimizer. Loss. Oh yeah, sure. Thank you. Oh, who uses optimizer, man? I mean, who uses STD, man? Okay, that's true. Optimizer equals Adam. That is fine. So now we have to train our model. So I mean, I don't want that thing. It is really annoying me. Where is the AI? No, thank you. No, thank you. Yeah, but uh, okay, I don't want you. You are also in. Okay, thank you. All right, model start train. Let's start training for step in number of steps. And let's define hyperparameters here. But number of steps 100. So for each step, we first have to do forward pass. So model, I mean, what? I think this is not loss, it's loss category. Uh, First, we need to do a forward pass. So x equal, yeah, let it be x. Model of, let's say x. I don't know what will happen if I run this. Int objects not, okay, obviously. Matrix 1 and 2 cannot be multiplied. 2 by 3 and 2 by 5. Okay, who is multiplying those things? Oh, so I have to do this. 2 by 3 and 2 by 5. Okay. I mean, for the time's sake, I'll just make both of it this. Do I find? Do I find? Oh, I mean, okay. Uh, this two represent number of rows. So let there be 100 rows, and the number of features be 2. That is better. And here, the output, I want the just 100 numbers. That's what I want. So I'll just put, I think I can just put 100 here and expect the whole things to work. Yeah, actually that's all. Okay, so we did the forward pass. Now we have to do loss calculation. Loss category of x comma y. Nice. Uh, Now we do loss dot backwards, and we do optimizer dot step. This is it. And before everything, we do optimizer dot zero grid. 10 subjects have now attribute backwards. Uh, hmm. Why the? Oh, it's backward. Yeah, my bad. So let's also open loss. Let's do loss dot item. Okay. So the loss is going down obviously. Okay, so we made a neural network that very well predicts the output. But pretty sure the it's not using my GPU at all. So let's put the model CODA. Let's also assert here. Use what is it called? And CODA instance, GPU instance. That's fine. Now, yeah, instead of 100, let's do 20, and it's on you. Okay. So let's do x equal to x dot to CODA. Similarly, uh, how about now? What is this warning? Use a warning using a target size that is different to the input size. Likely to incorrect result due to broadcasting. Since I think I'll have 10 features. This is one. And all you will have 10. Under by 10, 2 by 10. 2 by 5. Oh, I defined a model here, didn't I? Okay. Uh, I'm not sure. I'll ask ChatGPT if I'm doing anything wrong. Let's go here. Let's put all of those here. And let's go it's not an error but sharp. The model's output y product y predictors are compatible with the size of y in MSC loss. Wait, wait. You're saying that y and y prod has different dimensions? Not short, right? Print y dot shape, comma y prod dot shape. Oh, okay, that's a big issue. Goodness gracious. Okay, so let's go like I don't know. Okay, why is y predicted 100 by 100? It should be 10 by 100. Wait, what? Oh yeah, my bad. That's better. Much better. Nice. Uh, so the loss is not decreasing. Oh, it actually is. If you go 6.5, will stop. I think we would need to decrease the learning rate for that. No, that's true. Okay, I get the you get the point, right? Okay. This is on by error anyway. Okay, so okay, so let's for this thing, how about we make the more this one bigger, 500, let's say 500, 500, and run the whole thing. Control of line. Okay. I don't know, so I have to run you. Oh, that's it. Okay, let's run for, let's say, 1001. So control F9. To run 1 second. I was expecting it to run slower. Control F9. That's lore. Okay. That's too many bucks. Control of 9. Took 4 seconds. It takes 3 to 4 seconds. So, how to measure? Is there some decorator or something? The run time of a loop in Python. I'm expecting some sort of time age. Define my loop. The lap time equal to time age of my loop. Number 100. Another loop 100 times. Okay. Using decorator. Oh, decorator only works on functions. This is not function, right? Yeah. Okay. So we can like t1 equal to time dot time, t2 and t2 minus t1. We can also do import time. Okay, 3 seconds. If step percentage 100 equal to 0. 2.53 seconds. 2.5 seconds. Okay, now what if we replace CUDA? Okay, I accidentally press Control R. I want to do like find and replace. What is the Control Shift F? No. Find and replace shortcut. Control H. Okay. So find the CUDA and replace that with the CUDA and replace that with device. Okay. I thought there was one more CUDA. Device and the device equals CUDA. So can I do this now, right? I can? Really? Yeah, obviously. So let's do two device. Obviously, 2.6 seconds. So if I change this to like CPU, okay, that's lower. Let's put this thing back to CUDA and let's do model.compile. Can we are slower? Do I have to do model equals model compile or no? Okay, I don't. Okay, for probably it is not showing much difference because the task is too small. Yeah, this is actually slower. Compiling your slower runtime. Okay, cool. Mm, multiple losses. Okay. So if you have multiple optimizers, we should be like optimizer at 0 guard. Okay, 0 1. Calculate loss. What is scalar? Scalar equal to ortho amp. Okay. AutoGuard mechanics. AutoGuard is a reverse automatic differentiation system. Conceptually, AutoGuard records a graph. I mean, just ensuring my audio. It's all good, right? Okay. AutoGuard records a graph recording all of the operations that cater the data as soon as you execute operations, giving you a direct acyclic graph. Okay, with whose leaves are input tensors and roots are output tensors. Okay. You make the computational graph. The gradients for non-differentiable functions. Gradient computation using automatic differentiation is only valid when each elementary function are being used is differentiable. Unfortunately, many of the functions we use in practice do not have this property. Square root also does. Okay. To try to reduce the impact of the functions that are non-differentiable, we define the gradient of elementary operation by applying the following rules. If the function is differentiable and if the gradient exists at a current point, use it. The function is convex, use a subgradient. Okay. It's a rule. Then what is fun? Pytorch custom operator threading and the torch script inference. What is torch script? What what is starch script? Way to create serializable and optimizable model from pytorch code. Uh-huh. Uh, PyTorch is an open source machine in the Torch library. Torch is an open source machine learning library used for creating base Torch, not PyTorch. Wait, what? Okay, this is Torch script. Okay. Import Torch. Torch will get that script. Define foo. Trace the function can call script functions. Hmm. Why is why is Torch script used? Model serialization and deployment. JavaScript allows you to serialize, say, a PyTorch model into a file that can be learned in an environment where Python is not available for practical, such as servers, embedded devices, deploy. Okay. Hmm. Faster inference, support for non-Python platforms. Okay. Torch script. Okay, we will use this if we are needed. Distributed data bar, extending PyTorch. Frequently asked question. That's one. Getting started with IntelliGB. No, thank you. Reproducibility. Language bindings. Okay, Tarp Python APIs. These are all Python APIs, right? Yeah. Okay, so there's so many APIs. My model reports code or runtime out of memory. As you ran out of the memory in a GPU. Since we often deal with large amount of data and byte, small mistake can rapidly occur. Let accumulate history across the training loop. By default, computation involving variables that require training. Gradients will keep in history. This means that you should avoid using such variables in computation which will live beyond your training loops. That is, consider the following training loop. Optimizer at 0 get output equals model of input. We made an last category. There should be input and output here, right? I mean output and the y here, right? The total loss. It's accumulating history across your training loop. Since loss is a differentiable variable with autocorrect history, you can fix this by writing total loss equal to plot of loss instead. Okay. Oh, that is a very fun thing to know, right? Because if that's amazing. That's really amazing. Like this is something I think I would do. But here, maybe not. Yeah, I would do tossed item. And tossed item would probably be an integer, right? I mean a float, right? That's it. Yeah, yeah. We'll see. Like print type of what is it called? Lost item. Yeah, it's a float. It's fine. Okay, I would obviously do or last item. But if we do this, if I did this, total loss will create a huge, what is it called? Computational graph involving every loss calculation throughout the this thing, which will massively create code or runtime issues. I think I want to try that. Total loss plus the equal to loss. Total loss equals 0. Can you do this? Let's go. GP memory. Can it increase much? Sad. I was expecting bigger improvements, man. Hmm. Maybe the model is small. Let's go 0, 0. And let's let there be 1000 and there be 1000. Let this be 100, this be 100. And we do control F9. What happened? 1000 by 500 into 5000 by 5000. Oh yeah, obviously. Control F9. This is the GPU usage. No, really? Okay, thank you. We're not going up. Hmm. Okay, but that didn't happen. Don't hold on to sensors and variables that you don't need. The scope of log can be larger than you expect. For example, intermediate result equal to G of intermediate. Intermediate live even while H is executing. Because its scope extrudes past the end of the scope, end of the loop. To free it earlier, you should use delete intermediate when you are done with it. Avoid turning RNs on sequences that you large. It will propagate through RN scales linearly with the length. So run out of memory. Okay, cool. Don't use linear layers that are too large. The memory requirements of the weights scales quadratically with the number of features. It's very easy to blow through a memory this way. You can trade off memory for compute using checkpoint. Okay, that wasn't much. But if I just remove this, okay, what is this? I comment that and then control F9. It actually increases. Funny. Um, that's so funny. Everything is happening exactly what I don't. in ways I don't want. Restart session and run all. Yes, thank you. Okay, the point is I shouldn't be doing things like these. My GPU memory isn't freed properly. PyTorch use caching memory allocated to speed up memory allocation. As a result, the value shown in NVIDIA SMA doesn't usually don't reflect true memory usage. If your GPU memory isn't freed even after Python glitch, it's likely that some Python subprocessors still alive. You may find them using gripping and manually killing them. Out of memory exception and cannot allocate memory. You may have to write some code to try to recover from memory errors. Try run model, except real-time error, runtime error. Yo, I can do that. That's so cool. Okay. I mean, I think it's easy to just, yeah, everything works. Anyways, but find a way but find that when you run out of memory, you don't recover code. Your recovery code cannot allocate either. This is because Python exception object also refers to the stack frame when the error was raised, which prevent the original tensor object from being freed. The solution is you move your auto memory recovery code outside the except class. Okay. Create data box returns random numbers. Return doesn't work with data parallelism. Reproducibility. Completely reproducible results are not guaranteed across PyTorch releases. Individual commits are different platforms. Furthermore, results may not be reproducible between CPU and GPU executions, even when using analytical seeds. Okay. However, there are some steps that you can take to limit the number of non-deterministic behavior. You can use starter manual state to set the RNG for all devices, both CPU and CUDA. Some PyTorch operation may use random numbers internally. Calling it multiple times back to back with the same input argument may give a different result, however. As long as you're using torture manual state instead. Okay. It is also possible for obtaining identical result from an operation that uses random number by setting torture manual seed to the same value between subsequent calls. For custom operators, you might need to set Python seed as well. Hmm. Random number generators in other libraries. Hmm. CUDA convolutional benchmarking, avoiding non-deterministic algorithms. Okay, fine. Okay. Now I think I heard of another library called Torch Info. Oh wait. Oh, this is 0.7 instead of other one being 0.9. I'll try again. Runtime. Mm, run out. If this thing comes out to be 0.9, that is insane. Like 200 MB just because of this stupid what is it called, assignment addition. Yeah. Now let's see this, guys. I also want to do like some other thing. Yeah, I'll do it later. All right. Torch. Torch is a package that contains data structure for multidimensional tensor that defines mathematical operation of the tensors. Additionally, it provides some many utilities for efficient serialization. Okay. Get the default type. Number of elements, return total number of elements in the input tensor. Get the default transfer tensor to be allocated on the device. Set. Price is 11 already. Oh, number of is 200, 2000, okay. Creation operations. Tensor. Construct a tensor with no autocad history. Creates a tensor from numpy array. Converts data into tensor. Sharing data and preserving autocad history if possible. Creates a CPU tensor with storage backed by memory mapped file. Bernoulli. Normal. Return tensor normal numbers. Rand. Tensor filled with random numbers in uniform distribution. Math operations. Cool. Spectral operations, like I said. Wait, now I have heard of another library in PyTorch which is called Torch Info. No. Pip install Torch Info. And instead of doing this, I want to do from Torch Info import summary. And I want to do the summary of model. And this will give a TensorFlow like, yeah. What are the other parameters? Input data, batch dimension, column with the device, height hours, model statistics. Total parameters 25,000. So these many, what is it called? Parameters. We are using float 32. That is 4 bytes per this one. So times 4, these many bytes are required. So these many bytes will be required. So we want to divide this by 1024. So these many kilobytes, 1024. These many megabytes will be required to represent this model. Basically 100 megabytes. What if I do one more 00? How about now? This is arguably going to be way more. Whoa, 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 whoa. Look at the RAM usage. Okay. I thought it crashed. Okay, so total number of parameters is this many. Ooh. So I'm going to divide this by 1024 again. That's 9 GB. Yeah, makes sense. Makes sense, sir. All right, sir. That makes absolute sense. Now, you know what? Probably I cannot train the model, right? How about instead of 50,000, we go. No, why are you not 50,000? Okay, anyways, I mean, we're going out of way. Okay. Mm-hmm. We have linear layers, dropout layers. Oh, we have transformer layers. Okay. I need a transformer, a transformer model. Uh, so what can I do with that? Like, can I make a like kill this thing and do like model 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 equals nn data transformers y. Will that work? Okay. Transformer. Okay. Then what is the name? Oh, T is capital and that is nice. Enable nested error, but self-dot nested tensor response. Uh, okay. I don't know what that means, but sure. What if I compile it? Okay. What if I run you? Transformer are forward missing one position argument TGT. I think I just want to like, yeah, I want to run this. Wait, what if I run this? Oh, let's go. Transformer encoder and a transformer decoder. Okay, this is a encoder decoder transformer. Trainable parameters are these many, which is like a lot. What the hell? Oh, okay. that is 100 MB. I kind of want to, you know, make this thing work. So I'm going to give you to Cloudboy. Make this work. Okay. Create a transformer model for a regression. I want to use NN dot transformer. Wait, what? Where did you use it? Oh, okay. Oh, it's like a layer. It's a transformer layer, isn't it? It's not a model by itself. What is a model? Oh yeah, there is an encode and a decode which is separate. There should be some examples in here somewhere, right? Like go here. If I do this, if I do this, and run you, yeah, you are. Yeah, that worked. Windows 5 control. What is SRC and TGT? SRC is about like source. Oh, oh, this is X and Y, yeah. Okay. So if I do given X and Y here, what would happen? The feature number of source and target should be equal to d mod. Okay, sure. I will do 100. I have no issues with that. Data is what you think data should be. The feature number of source and TGT might be equal to d model. Okay, so arguably I should be able to put like d model here, right? Okay, we gave me the hard code, which is in my opinion absolutely fine. Yo, it actually works. Look at that. uh, restart session and I'll run you. So we'll have this is the input data, your target data for each 1000 instance. Given 100x, I want to predict one. We have CODA, we have parameters, input projection. So I take input into D model. Okay. Wow. I made a very small transformers, didn't I? That's so cool. I can just use that with Python. I mean PyTorch. I didn't know it was possible. Okay. So we can also do recurrent layers. Oh, okay. Now do RNN. Do the same with the RNN using this one. We have the same kind of implementation. We also do the input projection. Okay. Can I like literally change this one and nothing else and expect the whole thing to work? Like what if I put RNN here? That unexpected argument. Okay. Sure. But what if I change this only thing? Now it will definitely work, right? Oh, okay. Yeah, that's so cool. Yeah, what about convolutional functions? What is star coded or memory usage? Then the percentage of time I will pass the sample period during which the global memory. I don't know what that means, but I will definitely run you. Uh-huh. You can also do the import by nvml. Okay. Okay, cool. I don't know what that is. NVIDIA tools extension. Mm. Tortured compiler, torch distributions, tortured hub, tortured JIT, tortured linear algebra, tortured monitor, tortured onyx, tortured optim, DDP communication hooks. Okay, I want to look at that. Distributor framework maybe not today. Torched mass, torch nest, torch size, torch parts, torch storage. Torch hub is a pre-trained model repository designed to facilitate research reproducibility. Okay. Defined as net 18, pre-trained equal to false. Mode equal to underscore as net 18. Pre-trained. GitHub. Where am I download model saved? Okay, I want to use some model. I kind of want to go there too, but maybe in the next stream. Yeah. Yeah, I should have started from with the learn, right? Obviously, but here we are. Probably there is Torchlight Hub somewhere here. Definitely, right? Oh, interpretability. So cool. Interpretability. Captain. Condensation. Visualization. Optimization. Okay, we'll learn the Torchlight Hub. Okay, I can use. Okay. Let's just do some clothing. Use torch dot hub to train a, let's say, VGG19 model on MNIST dataset. So we make the necessary imports. Let's do a model equal to toss.hub.load and vision and vgg return equal to true. Modify the first layer of for nest one channel instead of three. Okay, we have to do that. Modify final layer for 10 classes. Okay, oh, that's so cool. We can just do that, right? But funny, it is different. It's features and classifier. We define, we transform the data, we load the data, we use the data loader. Oh, it's so fast. Criterion equal to n cross entropy for number of epochs. Well, oh, okay. Okay, we'll try. I mean, anyway, it will take some time to load the model, doesn't it? In the meantime, we will try this thing. Model train running loss equal to 0. For each image label and enumerate, we load the image to the device, which is CUDA. Optimize the we take the output, loss, and up, okay, that's our. Now we update the running loss. We print the. Oh, I can do is to get the 100th on that. That's cool. Validation. So after the training is over, no, for after each epoch, we do validation. We with the task.now grad we perform inference on the what is it called validation data set. Okay, downloading mnest, downloaded VGG19, which is 548 MB. Well, 76 Mbps. That's a dream, boy. That's a dream. Okay, we've been learning this for long, right? For a very long time. What's mnest? How big is mnest? Mnest is very small. It's black and white, man. What do you mean? Yeah, Tasha Dab is cool. It is just like Hugging Face, right? Just one line of model.lot basically. Tasha.up.lot. Other thing is what I forgot the exact wording, but something that lot and the name. That's all I wanted. That's all what was needed. Mm-hmm. Lot by I saw slow runtime restart session. Yes, run. In the meantime, it's something else. What should we do? Let's. Mm. Startup works by importing the package as if it was installed. There are some side effects introduced by importing in Python. For example, you can say new items. Normal pattern behavior. This also mean you may have import errors and imported different modules from the different repo. If the repos are the same sub-package name. The workaround for these kinds of import is to remove the offending sub-package from session modules dictionary. So I find this GitHub issue. Another limitation that is worth mentioning here, users cannot load two different branches of the same repo in the same Python process. It's like it's just like inserting two packages the same name in Python, which is not good. Mm. Cache might join the body and give you surprise if you actually try that. Of course, certainly fine if you load them in separate processes. Multi-processing boys. Okay. This thing is dead. Okay. The mnest downloading link doesn't work. More reliable data loading approach using Hugging Face. Okay, sure. Import dataset. Pip install datasets. Wouldn't there be an issue in pytorch actually? No, pytorch.org. Like GitHub. mm, Go like pytorch. PyTorch. Issues. Let's go mnist. Mnist with the torch. No? For researchers. Vision. Mnist. PyTorch. Torch dataset. I mean torch vision dataset. Start vision dataset. Okay. Torch vision dataset.mnist. This should actually work, right? So you didn't work? Okay, bro. Import torch vision. So here, hub.dot. Torch vision dataset. Okay. Is this website down? Uh, it's down for everyone. It's not just the server's not responding. Okay. With that mnist dataset, torch vision. There's no issue in here. Why though? which is the latest pytorch version 0.2. uh, yeah, let's go here, let's go here. My audio is fine, right? Wait, all is well. Okay, so yeah, latest Python both Coda and Coda. PyTorch version is 2.5.1. Okay, that's the latest stable PyTorch version. So I'm going to pip install torch equal to 2.5.1. Yeah, anyways, let's move on. Right, that thing doesn't work. Cool. Caching logic. Okay, that's torch.hub. Tomorrow we'll learn. Yeah, torch script then. JavaScript is a way to create serializable and optimizable models from PyTorch code. Any JavaScript program can be saved from a Python process and loaded in a process where there's no Python dependency. That's so cool. We'll try that. Torch or linear algebra. We can take Noam Chomsky. Hmm. Compute the solution for a square system of linear recursion with unique solution. Okay, all these things are in there. We attach a monitor. Provides an interface for logging events. Okay. Torch at Onyx. So we have a model. Do we do this? Then torch at onyx.export and then the model will be onyx. Then we can run the model on onyx. We'll try this too. That is an optimizer, constructing an optimizer. Cool. Communication hub is a generic interface to control communication current across. What is DPP? DPP in PyTorch. Distributed data parallel. Okay. Yeah, guess that's it for today. So yeah, thank you for watching. I think I'm gonna end the stream now. Thank you.